Okay, so on this problem, they're wanting us to, again, we have to get rid of the root from the bottom, right? That's always the name of the game, get rid of the root from the bottom. But the trick on this one is that there's also a plus sign. So let me write that note. When you have a root and plus, or adding, subtracting, let's just say. Adding, subtracting in the denominator. So when you have a root and adding, subtracting in the denominator, you must multiply top and bottom, top and bottom, by the entire denominator with opposite sign in the middle. And it's even got a special name. It's called the conjugate. I'm not going to quiz you on the name, but so in other words, so here's the mistake. We've done these before, and you don't want to make this. A lot of people go, oh, okay, I know how to do this. You just multiply by the root 6 part. That'll take care of it. That'll fix it. No, that won't fix it. That's not enough. It's because of the fact that we have this adding, subtracting in the bottom. You have to multiply by 6 plus root 6. Top and bottom, the whole thing. And an opposite sign in the middle. So we had a minus in the middle here. So I did plus top and bottom. You see that? If originally, now, if the one you have has a plus in the bottom, then you would have to multiply top and bottom by minus. Everybody tracking with me? You see that? Opposite sign in the middle. So whenever you have a square root with adding, subtracting, that's the big deal. When you have a square root along with adding and subtracting in the denominator, you've got to multiply by the whole thing, not just the root part like we did on some of the other ones, right? Everybody seeing the difference? If this was just minus 5 over 6 times root 6, I wouldn't do the whole thing. I would just multiply top and bottom by root 6, no big deal. I wouldn't use this 6 in the front. I wouldn't care. Why? No adding, subtracting. A good way to think about adding, subtracting is it glues things together. Be a helpful thought for you. Adding, subtracting, it's kind of like it glues things together. And so whenever you have it, you have to use the whole thing. They're glued together. Like these guys are glued together. So you got to use the whole thing, but opposite sign in the middle. Now, why opposite sign? Because it'll work. Let me show you. All right. So having done that, here we go. Well, what are you going to do? On the top, you're going to multiply boom and boom. This is going to distribute, isn't it? It's going to distribute on the top. Here we go. Minus 5 times 6. Minus 30. Minus 5 times root 6 is minus 5 root 6. It'll stay outside, right? Remember, outsiders with outsiders, insiders with insiders, no crossing the line. So the minus 5 multiplied the 6, but the other one just stays on the outside. Okay, now what about the bottom? You know how to do that bottom, right? First to both, second to both. Here we go. First to both. Right? There's really invisible parentheses here. Right? You're multiplying 2 things with 2 things. You know how to do that. First to both, and then after I do that, the second one will go to both, won't it? First to both, second to both. You've done this before, right? And as you multiply, remember, outsiders are going to multiply outsiders, and insiders are going to multiply insiders. There's no crossing the line. So here we go. 6 times 6. Well, it's just 36. And then 6 times root 6. Well, the 6 stays on the outside, the other 6 stays on the inside. All right, now, this is a minus root 6. Take his sign with him. That's his baby. Minus root 6 times 6. Minus 6 root 6. Right? Outsider stays outside, insider stays inside. Last part, minus root 6 times plus root 6. Negative times 5 is negative root 36. Did you track with that? See what just happened there? Root 6 times root 6 made root 36. Negative times positive is negative. Insider times inside. Now we're not done. Whoa. What are we even doing here? What are we doing here? We're trying to get rid of the root from the bottom. Remember, we can never have a root at the bottom. That's the name of the game, right? See how we had this root in the bottom in the beginning? We're trying to get rid of the root from the bottom. We can never have a root in the bottom. Well, we got a whole bunch of roots now. Yeah, but they all go away. You see it? You see them going bye-bye? These two, first off, are just going to cancel. Positive 6 root 6 and negative 6 root 6. Bye-bye. Do you see now why we use the opposite sign? You see how that worked perfectly? Now, what about the other one? Well, this is just 6, isn't it? The other one's root, no more roots. You see how this got rid of the roots? So what do we have now? Minus 30, minus 5 root 6 over what's left on the bottom. Just 36 minus 6, which is going to be 30 in just a second. But I want you to see there's no more roots in the bottom. See how that worked beautifully to get rid of the roots from the bottom? You see that? These canceled out. That's why we use the opposite sign. That way you get one positive and one negative, and the roots go away. That's why this works. That's why there's a whole name for it. Conjugate. Opposite sign in the middle. So again, in other words, if they started with plus on the bottom in the middle, I would have used minus. Top and bottom. You got to do the same thing top and bottom, whatever you do. You can't change the problem, right? You're just changing the way it looks. Fancy plastic surgery. You're making it look different. That's the same as it was. Tracking with me? Whatever sign they have, if they had plus on the bottom in the beginning, I would have used minus top and bottom. They had minus, so I used plus top and bottom. Opposite sign in the middle. That's what gets rid of the roots. Now, we're not done. We have a couple more interesting steps here. Let me show you. Everybody good so far? Is that making sense? This root 36 just became plain 6, right? Whenever you root a number, the root vanishes. Now, on the bottom, 36 minus 6. 30, right? Minus 30. Minus. Average is on the bottom. 36 minus 6. That's just 30. Now, we've done a lot of good work to here. And at this point, it's so easy to misstep. Here's what is so tempting to do. You say, oh, good, just cancel those 30s. No, you cannot, you may not cancel those 30s. You can't do it. Why not? You cannot cancel part of an added, subtracted. Remember me saying adding and subtracting is like glue? This 30 and this 5 root 6, it's minus 30, I should say, and the minus 5 root 6, they're tied together, they're glued together. You cannot break a glue bond. You cannot take part of an added, subtracted thing. Why not? Math just wants to make hard rules to make it challenging. No, I'm kidding. I know a lot of people feel that way. It's just not true. Let me prove it to you. What if you had, I don't know, like 10 minus 2 over 2? What is that really? Well, that's really 8 over 2. It's really 4, isn't it? If you cancel the 2s, all of a sudden it's 10. See, this is not true, is it? See how it's just simply not the truth to cancel out an added, subtracted, part of an added, subtracted thing? That's really 8 over 2. It's really 4. It's not 10. This is not true, is it? So that's the deal. You cannot cancel part of an added, subtracted term. Well, then what do we do? Do we just stop there? No. No. We do have to simplify. How do you simplify? You divide all 3 of them by 5. If all 3 of them are divisible, I mean this 5, this 30, and this 30. If all 3 of them are divisible by the same thing, you need to do it. It's all or nothing, because remember, they're glued together. So you divide them all by 5. And what do we get? Minus 6 minus root 6 over 7. And that's our final answer. Why? Why is that my final answer? Well, first off, do you see what happened there? All right, I divided all 3 of the outside, just the outsiders. I'm not doing the inside. Remember, it's outsiders and outsiders. Insiders are in a whole different world. They're in prison. We're not going there. I'm just doing the outsider, outsider, and outsider. So if all 3 of them are divisible by the same number, you do need to do that. You must simplify that. I divided them all by 5. You might wonder what happened to this is a 1 if you want, right? 5 divided by 5 right here. Come on. 5 divided by 5 is 1. Right? Now, can I cancel these 6s? No, same problem, right? Added, subtracted things you cannot cancel. Adding and subtracting is glue. Let me maybe help if I wrote that rule out for you. Added, subtracted items are glued together, meaning they're a package deal, right? They're connected, they're a package deal. Simplify both. Simplify both. If you can't do both, you can't do anything. They're glued together. Right here, right here I did both. I did both those two that were glued together and the bottom. I did all 3. So it was okay. But right here, I wanted to do just these 2. Can't do it. I said, well, yeah, we'll do this 6 also. No, he's in prison. Totally different world, right? You keeping all these rules straight? A lot of rules, right? Outsiders with outsiders, and then pluses and minuses are glued. So you can't do these 3 because this guy's in a whole different world. He's in prison. So then just these 2? No, that breaks the glue bond, right? This -6 and -1 there are glued together by that subtraction, which means they are a package deal. You simplify them both, or you do nothing. All or nothing. Package. It's like shopping at Costco or Sam's Club, those big warehouse stores, right? You go to grab one milk, it's plastic to another one. You can't take your sisters to Costco and just cut the bond and say, thanks, I just want one today. Right? That's the whole deal. They sell you a bunch and you get a cheaper deal. So that's what pluses and minuses are like in algebra. They glue things together, making them a package deal. So that's what I did back here, right? Right here, these guys were glued, but it was okay. I did both of them by 5 and the bottom. So that was okay. But if this had been like a 7 here, I would have stopped. Does everybody see that? That's important that you see that. If that had been like a 7 there, I would have stopped because then that's not divisible by 5. There's nothing that both 30 and 7 are both divisible by. So we're done. We just stop right there. It's all or nothing. It's both or nothing. It's a package deal. Adding and subtracting. Right here, I can't do both of those by 6. So I'm done. This is my final answer right here. I want you to put the A on the top, the B on the bottom, and the A and the B blanks. So there we go. There's a lot to that one.